Hey students, this is lesson 9.1. The Get Ready here is a good review of some important concepts. We're going to learn about quadratics here. And specifically, we are going to graph quadratic functions of the forms y equals ax squared and y equals ax squared plus c. All right, go ahead and do this review, and there's some important vocab here. Make sure you pay attention to that. All right, here's an important concept here, the standard form of quadratic function. A quadratic function is a function of the form y equals ax squared plus bx plus c, where a is not equal to 0. The graph of any quadratic function is a parabola. And here's some important things about that parabola. It will be symmetric. There will be an axis of symmetry, so the line of reflection, if you will. And there'll be a vertex, which will either be a minimum if the parabola opens up, like this one, or a maximum if the parabola opens down, like this one. Okay, so we're going to go ahead and look at this graph, decide what the vertex is. And as we can see from the key concept up above, right here is going to be the vertex. And since that is at the top of the function, we're going to say that that is a maximum. So the vertex will always be either the maximum or the minimum, and in this case it's a maximum. And then we just want to write the coordinates of that point, and they are -1, 4. All right, you try that. All right, the next thing we're going to do is learn how to graph functions. One thing I want you to think about as we're graphing this function is think about the shape that you know it's going to be, because this is a square. So you know it's going to be a parabola. And parabolas are symmetric, so that can help you find points and help you graph it. Because parabolas are, so if we have some symmetry, we can just match up points. And it also will have a minimum or a maximum. So once you get to that minimum or maximum, you should see a pattern occurring. So let's go ahead and then we also have to give the domain and range. Remember, the domain are possible x values and the range are possible y values. So once we get our graph, we'll look at that. Okay, let's just make a table here, and so this is our domain, our x values. These are just the ones we're choosing. We could have more domain values also, and our range. And I think I'm going to start with this graph goes, the domain showing here goes to -7. But if I do -7 squared, that's 49, and half of 49 is 24, and I don't think that'll fit on my graph. So I'm going to go -6, -5, -4, -3, -2, -1, 0. And it seems like I'm doing a lot of points, but you'll see that they go pretty quickly if we think about the shape that we're going to get here. So I'll just do one with you, and I'll let you fill in the rest. So -6, we're going to do 1/2 times -6 squared. Remember, a negative times a negative is positive. You got to do powers first. So half of 36 is 18. And then for the next one, I'm going to do 1/2 of -5 squared. -5 squared is 25. Half of that is 12.5. Go ahead, you fill in the rest. I'll check back with you. Well, I hope you noticed that the numbers started to repeat once we hit, in this case, the minimum at 0, and then they just repeated. So we didn't have to recompute those. And we should also get the same sort of an idea with the graph. So if I graph the first few points, -6, I'm just going to put some marks on here to help me see where I'm at on the graph. Okay, so -6 is 18, that would put me here. Then I'm going to be at 12.5, then at 8, then at 4.5, 2, half, 0. Now these are all going to repeat, so I'm just going to go straight across from my other point there and match it up using the symmetry of the parabola to help me out with that. And now I'm just going to draw in a line to look like a parabola, a little bit of a curve. All right, and now let's look at that graph and decide what the whole domain is. So the domain is all input values. So what values can I square and then take half of? And I hope you're thinking you could do that to any numbers. So all real numbers is the domain. And remember that we can use interval notation to show that. So from negative infinity to positive infinity. And then the range, now that is not all real numbers because there's a minimum here. So the range is like what possible y value. So I'm going down here, starting way up here at infinity, if we kept going that way. And notice I stop at 0. So my range is all numbers from 0, and it includes 0, so I should use a little square bracket there, from 0 to positive infinity. So really I'm saying all positive numbers are possible range values. So go ahead and you try that. All right, in this problem, what is the order from the widest to narrowest graph of the quadratic functions? And what I'd like you to think about is what are the outputs going to be? So if the outputs are really high numbers, then that means it's steeper. If the outputs are lower numbers, that means the graph will be flatter. So how do these outputs of each of these compare? So in this one, the outputs are squared then doubled. In this one, the outputs are squared multiplied by negative 1/3, which is like dividing by 3. So the outputs are definitely going to be smaller here than the outputs of this one for the same number. And then this one, the outputs are quadrupled and multiplied by 4, otherwise the same. So the widest graph, just thinking here, is going to be the one that is dividing by 3, the outputs by 3, and that's this one. So this will be the widest. And then this one, and then this one will be the narrowest. I was thinking we could also just look at the graph real quickly, just using a standard window. So here I'm going to graph them in the same order that they're listed. And notice that okay, there's 2x squared. That's negative 1/3 x squared. And that one is 4x squared. So in order from the widest to narrowest, they go like that. All right, next problem. How is the graph of f of x equals 2x plus 1 different from the graph of 2x plus 2? And think about this. This part of the outputs is exactly the same. So in this one, we're just adding 1 to all the outputs. We've seen graphs before, but we can go ahead and use our graphing calculator to try that. Let's just see what happens to help us out here. All right, so I'm going to graph this. Now watch what happens. So this is 2x squared. Notice that has a minimum at 0. And the second one is a little bit higher. And I'm thinking you probably expected that, but all of them are going to be shifted up 1 unit because I'm adding 1 to the outputs. All right, go ahead and try that. Okay, one thing about quadratic equations is they can oftentimes be used to show an object in motion. And here's an equation that represents a child dropping a pebble from a height of 30 feet above a lake. The function h equals negative 16p squared plus 30 gives the height h of the pebble in feet after t seconds. what is the graph of this quadratic function? At about what time does the pebble hit the water? So I'm going to go ahead and make a table of this, and I'm going to pause while I do that, and so we'll look at some numbers for this equation here. You can see that the height drops off really fast and ends up being negative, and we only want to use positive values here because our time has to be positive, and our height above the ground has to be a positive number. So I think we can use our calculator here to get a little better idea of what's going on. So I'm going to set that up here. So I have my equation in here. I'm going to go right away to my window. I know that I don't want negative x values, and I know that around somewhere between 1 and 2 seconds this thing hits the ground. So what I'm going to do is just go from 0 to 2 for my seconds and maybe make this go up by halves. And my height has to be at least 35, so it has to be at least 30, so I'm going to go up to 35. I'm going to graph it and watch what happens. Okay, now remember these are half seconds here, so this is a half second, 1 second, 1.5 seconds. Okay, and now this I can estimate a little bit better. I can say it's around 0.4 seconds. Remember, one way we can figure out a little bit better using graph is using the trace function. And if I trace down, I can try and get y equals 0, which is the ground. And it looks like x is about 1.38. I can even be a little more accurate if I use my calculating option here and do number 2, which is find the 0. Press enter. It asks for my left bound, so I need to be on the left side of where it hits the x-axis. So I'll hit enter there. I'm going to move it a little bit past there. Hit enter again. Then hit enter one more time. And it says about 1.369 seconds. So 1.4 seconds, or about 1.37 seconds is a good estimate. When you do this next problem, if you have a calculator available, go ahead and do that. If you don't, just do it according to the points on here, and you can check back with your answers. Okay, that's the end of this lesson. We'll talk about some things about this so you understand it more in class. I'll see you next time.